You are welcome to AG 304, Statistical and Field Experimentation. Study Section 2, Techniques of Data Collection and Data Classification. Introduction. Raw data are unprocessed bits of information about some topic or a particular event, and the raw data need to be processed by subjecting it to some statistical analysis before it can really make any meaningful interpretation. And hence, when you have studied this study session, you should be able to 1. Discuss the techniques of data collection. 2. You should be able to explain the tabular presentation of data. And thirdly, you should be able to discuss the graphical presentation of data. The techniques of data collection. A piece of data is called a score or observation. A collection of pieces of data pertaining to a topic is referred to as variable. For example, the age of an individual is a score or an observation, while the age of the entire group is a variable. And with this, we have to note that data can be collected from respondents through the use of 1. Structured questionnaires. 2. Group discussion or interview schedule. Data could also be collected through phone or email. 4. Other methods of data collection are warranty card, distributors or store audit, pantry audits, consumer panel, the use of mechanical devices, and also projective techniques. Classification of data. Data could be classified as quantitative data and qualitative data. Under quantitative data, we have 2 other sub-classifications, which are discrete and continuous data. It is important to note that quantitative data can be counted or measured, and the example of this are age, income, years, farm size, inflation rates, etc. Now, qualitative data can also be classified, just like I said earlier on, into 2. That is discrete and continuous data. And for discrete data, they have distinct value with no intermediate point. Example of this are household size, population census, number of students in a particular class, the number of lecturers in a specific department, and so on. The value of a discrete data must be a whole number without fractions. And in the case of the continuous data, it can take any value, unlike the discrete data. And for example, continuous data are weight, age, height, yield of crops, temperature, etc. Now, the second major classification of data after quantitative data is the qualitative data. And the qualitative data, on the other hand, cannot be counted, neither can it be measured, but it can only be explained. Take for instance, male or female, scale of operation, opinion of people or group of people, These are referred to as qualitative data. Due to the fact that statistics deals with numerical data, qualitative data are also converted into quantitative data by coding it or assigning values to it. For example, if you have any data that involves male and female, then to each statistical analysis of such data, number 1 can be ascribed to the male, while 0 can be ascribed to the female. It is important to note that data could be in form of primary or secondary data. And when we talk about primary data, it means that the researcher himself conducts the experiment and has the direct data. That is, it is the researcher that obtains the data himself, and not that he actually have it from other sources, just like for the secondary data. Now, any data that had been collected earlier or documented earlier before the person who wants to perform the statistical analysis obtain them, then such data are referred to as secondary data. Now, data presentation. Data can be presented either in a tabular form or in a chart. And we have to understand that group data are usually presented in a table where the frequency distributions are being generated. Now, for ungrouped data, it can be arranged in an array without putting it in a table. Now, let's consider this example on the board. The following are the ages of lecture, open and distance learning center for nursing students. Just like you have on the board, these are the ages as you are being given in the question, in the example. That's 23, 34 up to 43. For ease of analysis, it is important to rearrange this set of ungrouped data that is being given. And by so doing, we arrange the data from the list. That is, we arrange them in ascending order. That is, from the least to the highest number. 17 can be seen. It is the least number in the set of the data set, and 44 is the highest in the data set. And from here, you can determine the mean, the median, that is the mean value, the median, and the mode. And when we are to do this, we have to understand that the formula for calculating the mean is summation x subscript I all over n, where x is the individual score in the set of data, and the n is the total number of the observations, and where this is the sign for summation. And by this, when we summate this, that is when we add up all the given data, that is 17 plus 24 plus 24 plus 24, at the end of the day we have 622. We have 622, then all over the total number of the observations, which is 20. That if you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So with this, we have our mean value to be 31 30.1. That is 622 divided by 20. And from here, if you want to obtain our median will be, since the whole data set is 20, that is the number of the observations contained in the given data is 20, and then 20 is an even number, then we pick the two numbers at the middle, that is 30 and 31. So if you count to the left, you have 9. If you count to the right, that is from these mid numbers, then you have 9 values again. So from here now, you now have 30 plus 31 divided by 2. Then from here, we have our median value to be 30.5. And of course, to get our mode, that is the mode in the question, our mode will be the number that appears, or the number that repeats itself most. And from what you can see here, we have 4. We have 24 to have repeated itself 3 times. And this is the only number that have repeated itself most. And hence, our mode is 24. Now, frequency distribution. When masses of raw data are summarized, it is important to distribute the data into categories called classes. And in determining the number of individuals belonging to each class or frequency, then a class width is usually developed. Now, the tabular representation of data by classes, including the corresponding frequencies, is referred to as the frequency distribution. And the frequency distribution is made from an array so as to condense the data by reducing the number of rows such that closely related values are grouped onto class intervals. Now, if we consider the data in example 1, that is on the previous slide, then we discover that it can be replaced in a frequency distribution table as shown in this table. Now we have categorized it, so we have created the class interval to be between 17, 20, 21, 24, 25, 28. Now, there is something that is peculiar, and that is the number or the range between each class interval. So now, we have 3 as the range. Here, this 1, 2, 3, 3, 3, and so on and so forth. Now, we have what is called the cumulative frequency and the relative frequency. Cumulative frequency is the number of observations in that class plus all the observations above it. It often indicates the total frequency of a set of class intervals. While relative frequency itself is also known as percentage, and it is used for comparing the frequencies in each class relative to the total frequency and multiply by 100. It is the frequency of the class divided by the total frequency of all classes and is expressed in percentage. Now, from the table we are seeing on the board, we have the class interval, the class boundary, the class mark, the frequency, the cumulative frequency, and the relative frequency. Now, from here, just like I explained earlier, the class interval is as seen here, and the class boundary will be a 0.5 being subtracted from the first number of the class interval. So now from here now, 17 minus 0.5 will give us 16 will give us 16.5, and that is how we have this. And 20 plus 0.5 is as a result of what we have here, and so on and so forth. And the class mark is the addition of the class interval, that is 17 plus 20, then divided by 2. That's how we arrive at 18.5, and so on, even to the bottom of the table. Now for the cumulative frequency, the cumulative frequency is, you start with the first one, then you add 3 to this. That is 3 plus 1, we have 4. 4 plus 5 plus 4, we have 9. 3 plus 9, we have 12. 4 plus 12, we have 16. And 2 plus 18, we have 20. And for the relative frequency, we have 1. For this, we have 1 divided by 20. That is the total frequencies. Then times 100. It is equal to 5. And like that, up till the bottom of the table. Now this is the graphical presentation of data. And under this, we'll be considering the histogram. The histogram consists of rectangles and vertical bars or columns, just as we have on the board. Now, these columns have heights that are proportional to the frequencies in each class interval, and the horizontal axis, which is the x-axis, represents the class boundaries to ensure that bars are not separated, and the vertical axis represents the frequency of the observations. Now, under the graphical presentation of data, this is the frequency polygon, and the frequency polygon is a line graph joining the midpoint of the class interval. In a frequency polygon, a class mark is located in each class interval or class boundary, and the horizontal axis of the chart, just as we have on the board, has the class mark instead of class boundary as obtained in histogram. And in fact, that is majorly the difference or the major feature that differentiates the frequency polygon from the histogram. And for the vertical axis, the frequencies are arranged here in the order of the class mark, and a line is normally made to join all the points together, and this curve is called the frequency curve or the frequency polygon, just like we have. So a line joins them together. Now, under the graphical presentation of data, we still have what is called the cumulative frequency curve or polygon. Now, a cumulative frequency curve or polygon can be formed by plotting the cumulative frequencies of the distribution on the vertical axis and the upper boundary on the horizontal axis, which is the x-axis, just like we have on the board. Now, using the same data in table 1, in the previous example, that is example 1, now the cumulative frequency curve of the given data there can be plotted as we have on the board here. And hence, we join the points together with a curve. Sometimes the French curve is being used for this purpose. In continuation of graphical presentation of data, let's consider bar chart. A bar chart is a graphical display of frequency distributions in bars, and the bars can be vertical or horizontal. depending on the statistician, and they are being divided into sections, and a space is usually left in between each adjacent bar so that the categories are separated. Now, for example, the table that we have by the left hand side here, this table shows the value of Nigerian export of groundnut between 2001 and 2005 in Naira on the table below and in a bar chart. Just like I explained, just pick, we have the years to be the horizontal, this is the bar chart, this is the bar chart representation of this data. So for the year 2001, we have 67, and that's what we have. Year 2002, 52, 2003, 61, 2004, 64, and 2005, 80. Now, another graphical presentation of data is what is called the pie chart. And the pie chart itself is a circular diagram with the circumference of a total sum of 360 degrees, and in which each item is being represented by a sector of the circular diagram, and the area is proportional to the percentage or relative frequency of the data. Now, using the information in example 2, and hence we can calculate the percentage of each of the year. So but you first of all get the sum of the values for all the years. So you had for year 2001, 2, so you had these together, and that is how we arrived at this 324. Now from here, so you now be picking the values per year all over the total sum of the values. They multiply by 360. So for 2001 we have 74.44 degree, 2002 57.78 degree, for 2003 67.78 degree, and for 2004 we have 71.11 degree, and for 2005 we have 88.8 degree. Now from here, you now calculate the percentage contribution of each. So using the same information, just that it will now be multiplied by 100. So you get the percentage representation of each of the years. And by this, you now use this information in degree to get the circular diagram, which is referred to as the pie chart. And what you do is that for individual year, you obtain its degree representation. So it is the degree representation that we measure here. You start from the 90 degrees. You start from the 90 degree, then you measure it round. Now, one thing that you have to take note is that at the end of everything, you have the degrees together, that is the individual degree representation of the years, it must be equals to 360 degrees, and that is what makes a whole circle. Now with this, we have come to the end of this study section, the techniques of data collection and data classification. And I want to believe by now that you should be able to discuss the techniques of data collection as well as explain the tabular presentation of data. Also, you should be able to discuss the various graphical presentations of data. I enjoy you to go over the video clip once again to have a better understanding of all that you have learned. Thank you.